In this video, I'll show you how to inverse a matrix using the transformation method. This is part 1 of the series. Question 1 reads, find the inverse of the matrix using the transformation method. Our goal is to convert the matrix A into its identity matrix 1, 0, 0, and 1. So we have to convert every element here so that it looks like its identity matrix. So far, the top row already looks like the identity matrix. So this one is easy. All we have to do is convert this 2 somehow into a 0 and this 0.5 into a 1. And the rules are the following. You can interchange any rows, you can multiply a row by a non-zero constant, and you can add a constant multiple of one row to another. What I'll do first is try to convert this 2 into a 0. And the way I can do that is multiply row 1 by 2 and then subtract row 2 from the product of row 1. Here's what I mean. Multiply row 1 by 2 and then subtract row 2 from row 1. And since we're subtracting row 1 from row 2, only row 2 will be the one that's changed. Row 1 will stay the same. Since row 1 is staying the same, everything at the top remains unchanged, and we'll multiply each of these elements by 2, then subtract the elements in row 2 from the product. So 2 times 1 is 2, 2 minus 2 is 0. 2 times 0 is 0, 0.5 minus 0 is still 0.5. 2 minus 1 is 2, 0 minus 2 is negative 2. And lastly, 2 minus 0 is 0. 1 minus 0 is 1. We are getting very close to making our matrix look like the identity matrix. The last step is to convert this half somehow into a 1. And we can do that by multiplying all of row 2 by 2. If I multiply each of these elements by 2, I end up with, well, the top part stays the way it is. This becomes 0. 0 times 2 is 0. 0.5 times 2 is 1. The top part remains the same here. Negative 2 times 2 is negative 4. And 1 times 2 is 2. This right here is the inverse matrix of A. But how do we check if we've done this correctly? Turns out that if you multiply A by its inverse, you should end up with the identity matrix. So let's test for that. Let's take matrix A and multiply it to the inverse. 1, 0, negative 4, and 2. 1 times 1 is 1. 0 times negative 4 is 0. 1 times 0 is 0. 0 times 2 is still 0. So this becomes a 1, and this becomes a 0. 2 times 1 is 2, and half times negative 4 is negative 2. This becomes 0. 2 times 0 is 0. Half times 2 is 1, and that becomes 1. This is our identity matrix. Therefore, this is done correctly. Let's move on to question 2. In question 2, we have the matrix 8, 3, and 3 and 1, a 2 by 2 matrix. And once again, we want to convert this matrix so that it looks like its identity matrix. The only thing that we have going for us here so far is that this 1 is in the right place. You can take any path you like with this, but the thing that I'll do first is I'll start with this 1 and try to convert this 3 into a 0. I can do that by multiplying all of row 2 by 3 and then subtracting row 1 from row 2. Now since row 1 is being amended, only this row will change. Row 2 will stay the way it is. So I'm going to rewrite row 2 because that will remain unchanged. 3 times 3 is 9. 8 minus 9 is negative 1. 3 times 1 is 3. 3 minus 3 is 0. 3 times 0 is 0. 1 minus 0 is 1. 3 times 1 is 3. 0 minus 3 is minus 3. What I can do next is multiply all of row 1 by negative 1. And if I do that, watch what happens. This becomes positive, that stays at 0. This becomes negative, and this becomes positive. I remove the positive symbols, no need for them. We're getting awfully close to making this look like the identity matrix. The last thing that we have to do is somehow make this 3 into a 0. And we can do that by multiplying row 1 by 3 and then subtracting row 2 from row 1. Here's what I mean. Now, since row 2 is the only one being amended, I will rewrite the first row because that will remain unchanged. 3 times 1 is 3. 3 minus 3 is 0. 3 times 0 is 0. 1 minus 0 is 1. 3 times negative 1 is negative 3. 0 minus negative 3 is positive 3. 3 times 3 is 9. 1 minus 9 is negative 8. This right here represents the inverse of the matrix. How do we know we've done this correctly? Well, we'll take our matrix 8, 3, 3, and 1 and multiply it to negative 1, 3, 3, and negative 8. Let's see what we get. 8 times negative 1 is negative 8. 3 times 3 is 9. Negative 8 plus 9 is 1. 8 times 3 is 24 plus negative 24. That gives us 0. 3 times negative 1 is negative 3 plus positive 3. That gives us a 0. And lastly, 3 times 3 is 9 plus 1 times negative 8. And that gives us positive 1. And so there you have it. 2 examples on how to inverse a matrix using the transformation method. Make sure to watch part 2 where we tackle 2 more examples that are slightly more difficult than these.